After receiving an invitation letter, 3 friends, Sam, Khan, and Joe, begin their investigation of the secrets behind the inequalities inside the big house. They finally arrive at the front gate, where the first inequality is waiting for them.
To enter the gate, you must pour an acidic liquid into the right keyhole, and then an alkaline liquid into the left keyhole. When that's done, the gate will open.
I'm thirsty. I'm fairly sure we can drink it.
What, are you crazy? It could be dangerous. Let me test it.
Hey, what are those?
These are pH test papers. They're used to find out if a liquid is acidic or alkaline.
The pH scale goes from 0 to 14. pH is a chemical symbol. 7 represents neutral, less than 7 acidic, and greater than 7 alkaline.
We can see that this one is acidic and this one is alkaline.
Oh, all right. So now we know which one to pour into which keyhole.
What's the matter, Joe? Well?
He just smiled at me.
Huh? Let me get a closer look. Oh, that's the English mathematician Thomas Harriot. He's the one who introduced the symbols for greater than and less than.
That's right. For any 2 values, A and B, their relationship may be that they are of the same value. That is, A equals B. Otherwise, they are not equal. That is, A is not equal to B. If A is not equal to B, then it may be that A is greater than B, or that A is less than B. A is greater than B, A is less than B. These 2 relationships are called inequalities.
Sam, Joe, come over here.
What is it?
What is it?
Look here.
Huh? If you want to pass through this door, you must find the key with the greatest value. You only have 1 chance.
Oh, that's not difficult. We'll just try each one of the keys and see which one has the greatest value.
Can't you see what it says there? We only get 1 chance, you knucklehead.
Well, how on earth are we going to find out which key has the greatest value?
Take a look. There seems to be a clue of some kind. Let me see. Let's assume that the layout of the keys follows the layout of the number values on a number line, and then apply what we know about number positions on a number line.
The central number is 0. The numbers to the right are positive numbers, and the numbers to the left are negative numbers. On the number line, the values of the numbers increase from left to right. So the value of any number is greater than that of a number to its left.
Oh, right. For example, on the number line, 7 is to the right of 3. Therefore, 7 is greater than 3.
When we use an inequality to show the relationship between 7 and 3, we write it this way.
Hey, wait. The value of those numbers, they were positive. But what happens if they're negative?
Well, nothing different. Negative 2 is to the right of negative 5, so negative 2 on the right is greater than negative 5 on the left. We could write it this way.
On a number line, the value of a number on the left is smaller than that of a number on the right. The previous example, 7 is greater than 3, can be expressed as 3 is less than 7, and written this way. Therefore, in this case, if we go by the positions of the numbers on a number line, the door key furthest to the right must have the greatest value.
Good. I'll try the rightmost key in the lock then. Let's see. Behind us!
Strange. There must be a way out. Let's look around.
Hey, these look like pearls. Pick the largest and smallest of the pearls from this box. Those pearls will get you out of here.
I'm sure those pearls will open this door here.
Well, that's easy. All we do is take out the pearls and line them up in order of size. No problem. That's larger than that one. That's larger than that one.
You're wasting your time. Just say that this one is larger than this one.
That's using the transitive property of inequalities. A is larger than B, and B is larger than C. Therefore, A is larger than C. See what I mean?
Oh, so that means this is the largest and this is the smallest.
Yeah, that's right. Do you want to get out of here?
Of course.
Then let's go.
Right.
If you three really want to get out of here, you must first answer some questions correctly.
No problem. We're ready for a challenge.
A is greater than B. If to both A and B we add a positive value of C, what will be the result then?
Easy. The result is A plus C is greater than B plus C.
It's the additive property of inequalities.
And if C is a negative number, what is the result then?
Well, if a negative number is added, it means that a positive number is subtracted from both A and B. The result is A minus C is greater than B minus C.
That's the subtractive property of inequalities.
And if we multiply a positive number to both sides of the inequality sign, what will the result be then?
For an inequality, A is greater than B. If we multiply both sides by a positive value we shall call C, it's obvious that A times C is greater than B times C.
All right, and if we multiply a negative number to both sides of the inequality, what will the results be then?
The result is different. Let's take the previous example. 7 is greater than 3. On a number line, 7 is to the right of 3. But negative 7 is to the left of negative 3. That means negative 7 is less than negative 3. Negative 7 equals 7 times negative 1. Negative 3 equals 3 times negative 1. That means when both numbers are multiplied by negative 1, the inequality sign will be reversed.
Multiplying by a negative number is the same as multiplying by negative 1 and a positive number. Thus, the inequality sign is reversed. This is the multiplicative property of inequalities.
If there's a multiplicative property, surely there must be a divisional property, mustn't there?
That's right. Dividing by a non-zero number is the same as multiplying by the reciprocal of that number. Therefore, the divisional property of inequalities is similar to the multiplicative property. in that the main concern is whether the divisor is a positive or a negative number.
Bingo!
Look, the door's open.
Let's go.
Hey, Joe. The pH value of your face cream is 5.
So what's the problem? You said earlier that anything with a pH value less than 7 has to be acidic. Doctors say that acidic creams are better for the skin. Didn't you know that?
Tell me, Ken, if we don't know the actual pH value, but we know it's less than 7, and we only consider its integral values, then its value can be either 6, 5, 4, 3, 2, 1, or 0.
If we represent the pH value as an unknown x, then a pH less than 7 can be written as x is less than 7. This inequality contains an unknown, and is therefore called an algebraic inequality. Just like x is greater than 6, y is less than negative 1.
Let's take an unknown integer x when x is less than 6. X may equal 5, 4, 3, 2, and so on. And likewise, if x is greater than 6, then x may equal 7, 8, 9, 10, and so on. If we want to include 6 as a possible value of x, then we have to use these symbols, less than or equal to, greater than or equal to. When x is less than or equal to 6, the values of the unknown can be represented on a number line as we see here. The number line is the graphical representation of the inequality. This filled dot shows that the number 6 is included in the values. So the possible values of x include all the numbers to the left of 6, including 6 itself. But if x is definitely less than 6, this is its graphical representation on the number line. The hollow dot means that 6 is not included. X therefore is any number to the left of 6 on the number line, excluding the number 6.
X over 2 minus 5 is greater than 7. What does that mean?
I've seen these before. It's a linear inequality in one unknown.
In an inequality, if there's only one unknown and the index of it is 1, then it's a linear inequality in one unknown. Now, in order to solve this inequality, we first have to use the additive property. 5 is added to both sides of the inequality. Then we use the multiplicative property. Since the multiplier, 2, is a positive number, the inequality sign remains unchanged, and the result is x is greater than 24.
And we can show the graphical representation of this inequality on a number line.
Now then, if you can solve the following linear inequality in one unknown and act on its results, you can get out of here safely.
Let's see, minus 3x plus 5 is less than 11 minus x. That's easy. First, we subtract 5 from both sides of the inequality sign and add x to both sides. Then we divide both sides by negative 2.
Of course! X is less than negative 3. But what is that supposed to mean?
It must be something to do with unlocking the gate.
It's about time I did something. Stand back, okay? X is less than negative 3. Positive refers to a clockwise direction and negative counterclockwise. I have to turn the wheel counterclockwise for more than 3 clicks. 1, 2, 3, 4. Whoa!
Both sides of the inequality sign are divided by a negative number, so the inequality is reversed. The result of this linear inequality in one unknown should show x is greater than negative 3, and its graphical representation on a number line should be like this. The answer is x is greater than negative 3.
That means we still have to turn the lock counterclockwise, but less than 3 clicks.
Right. I'll try 2 and see if it works. 1, 2. Bye, Joe.
See you later, Joe.
We'll see you sometime.
Take it easy.
Bye.